Hans-Peter Mock is a visiting professor at the University of Costa Rica. He has he's been funded by the Johann Gottfried Herder program from the German Academic Exchange Service, DAD, and he's been at the University of Costa Rica since June 2022, last year, and he's going to be until 3 weeks, more or less. 3 weeks is going to be with us until by the middle of June this year. Dr. Mock has a background on plant biochemistry and physiology. He studied biology and physics at the University of Tübingen in Germany, where he also obtained his PhD working on plant cell wall synthesis. He then worked at the University of Braunschweig and then joined the group of chlorophyll biosynthesis at the Institute of Plant Genetics and Crop Plant Research, IPK, in Gatersleben. In 1998, he started a new group at the IPK, focusing on the role of plant secondary metabolites in the defense against biotic and abiotic stresses, but also on their impact on human health as being part of the daily diet. With this, I invite you to present your talk, and the floor is yours.
Thank you very much, Victor, for your kind introduction. And yeah, thank you for the time being here in Costa Rica already. It was a very exciting year for me, and I will try to summarize now. And so looking back and a bit forward. And so you mentioned already the Herder program from the DAD, and I'm very grateful that this program allowed me to stay here. And the program is meant for retired professors, for retired lecturers, and they should stay with the program in at least 1 semester at a foreign university. And it's also requested that the hosting university gives additional support. So, so the idea is that the retired professors should not sit alone at home, spend their time playing online games or solving crosswords. No, they should make them useful again, and they should go to a host institution and give their input in teaching and research, and also promote the exchange with this institution. So, and saying that, I would again give thanks to the DAD. This is I'm very, very grateful to that. And I'm also very grateful to 2 persons I should mention very frequently during my talk. This is Professor Salas and Victor. They both helped me in preparation, sorting the issues before I was coming, and during the whole year. So thank you very, very, very much for that. And now finally things were sorted. I arrived middle of June and the adventure started. Now I'm trying to divide my talk into 3 or 2 parts mainly, an initial phase and problems with the initial phase, a main phase, and also related problems to the main phase, and if there is time, some special problems. So now definition. What are problems? So in the initial phase, of course, the challenge is you have to cope with many, many administrative and organizational issues. You're coming to a new country, new place, and so on. And in the second phase, these are more scientific problems. And whereas you want to get rid of the organizational issues, you want to go into the second phase and you want to have scientific problems, because scientific problems are good problems. And if you solve many scientific problems, you can publish many papers. So speaking as a biochemist, you mentioned my background, the organizational issues and the administrative issues, they are kind of a competitive inhibitor in terms hindering the active side of your scientific endeavor. Okay, you have to get rid of this inhibitor. And so you have to dilute them out, you have to digest them to get into the main phase, to tackle then the real problems. And now you see the program also says to promote the exchange. And my host said, I feel responsible for this part for many years. So after 14 days, he said, I will leave now. I will go to Germany. Have a nice time here in Costa Rica. Goodbye. And he left, but he said, don't worry, don't worry. All my group will work for you and help to sort the issues, all the organizational issues. And I found myself in a very comfortable position. So like being in a paradise garden, the land of milk and honey, and many people around me who helped me to sort the different issues. For example, starting in the laboratory, preparing solutions, opening a bank account. I still remember Karen when we went to the bank, to the Banco Nacional. More things like that, growing Arabidopsis, designing plans for construction and so on. So this was very, very helpful. And one further example is I got help. I needed help. I was very naively, the day I left in Germany, I was going to the post office and sending some stuff which I could not transport with the 23 kilograms. So I was sending 2 parcels and they arrived a week later than I arrived, but then they got stuck at the customs. And now a very, very difficult phase started. And I would especially thank Mauricio in the administrative part here. He had to write many, many, many letters, making very detailed lists. And while I was over the weeks getting more and more nervous, he stayed very calm. And I'm very grateful for that. He has very good nerves. So I really want to appreciate his work. And in the final phase, of course, it also needed the diplomatic invention of Professor Salas and the director, Luis Barbosa. Thanks again for that. So finally, I could get all the stuff, send it here. And the lesson is prepare, when you send something, prepare it very carefully. Control what you are doing and communicate better with the people before you are sending something. Okay, so again, thank you very much for this support. All the time I kept Professor Salas and her secretary busy during that time. And one occasion, shortly after my arrival, I needed to go to the police station 2 days later. They wanted to have my digits. Professor Salas brought me there. She could not enter, it was forbidden. The situation was a bit bizarre. I had the feeling that I was not the only criminal present. And of course, I was very nervous. And I had to do it this conventional way, with the fluid. And I was nervous. And then it went wrong. And this officer, he was becoming more impatient with me. And I was becoming more nervous. But finally, I got out of the situation. Maybe remember how exhausted I looked to you after this experience. So the digits are there. I don't know if they are still needed, but in case you need the information there, the information is there. So conclusion from the first phase, I caused a lot of work to many people here at the Institute and the UCR, but I had no input from my side. So I was very lucky when teaching started really at the end, and I was happy to join 3 courses organized by these colleagues about plant metabolism, a PhD course, a thesis seminar. And one thing I have to say, I'm very grateful that, that I could jump into these courses. All the courses are very, very well organized. I really enjoyed that. And I'm also grateful that I could add my flavor. So it is a bit of cherry picking, but I think it was the idea that I should give my input from my experience. So it's about stress physiology, protein biochemistry, secondary metabolism, and a bit of paper writing and publishing. And now, while in the second semester, I have 2 of these courses, I also could start a kind of mentoria course, which is also about writing. It was not meant to be a course parallel to what Luis was or is doing as a competition, but it's more a course for advanced people, researchers who are fighting with the publication process. I think all the research scientists know that it is a continuous fight, which does not get better sometimes over the years. So I try to help, and in the moment I'm working on 2 of the papers and trying to help the colleagues and improve the paper, and hopefully we can come to a point where the colleague can submit. So now I'm going to research more, and as mentioned, my topics in general are stress physiology of plants, secondary metabolism. We heard very nicely about that. This is my general scheme, how I look to the control and the impact of factors on the profiles of secondary compounds. We heard about the importance of nitrogen. Of course, we studied also some environmental factors and genetic factors. And the outcome is then, on the one hand, the function for the plant, but also the function for the human nutrition. And one of the compounds shown here, this is a coumarin, which is one of my favorite substances. I worked in different projects I was working with compounds. It's a very nice fluorescent compound. So beautiful to see and very sensitive to be detected by fluorescence detectors. And one experiment from the past I would like to outline, this is a cold stress treatment experiment. So when plants are exposed to cold, then they start to synthesize compounds for protection. And I'm putting here the pathways, the relevant part of the flavonoid, of the phenylpropanoid pathway, where we see this coumarin, we see camphoros and quercetins, and we finally see also anthocyanins. And as a first thing, we can see that under 10 degrees, shifting plants to 10 degrees, the plants start to accumulating compounds for shielding. I will explain a bit more details in a minute. And this was part of a study where we were screening for compounds, mutants, which were affected in this cold induced regulation of phenylpropanoid metabolism. And we found 2 mutants, which had a different profile. They also responded to the cold, but on the expense of the scopolamine, the coumarin, or camphorol, they produced more anthocyanins. So we came up with a model, but this is not very much relevant for today. What I wanted to say is that phenylpropanoids here have the function to absorb energy-rich UV light, and they do this often by being accumulated in the epidermal tissue. So they shield the photosynthetic apparatus, but also other cellular structures. And I recently made a UVB stress experiment with Arabidopsis. This is the model plant we are using, and I brought Arabidopsis with me. These are the Arabidopsis plants, which I could luckily grow. Luis provided access to the growth cabinets for Arabidopsis. Esther helped me to grow the plants. And last Friday, I made an experiment. I exposed 6 Arabidopsis plants to outside, to very high light conditions. I should say, before the experiment, I measured these plants. I will also explain how, and they had almost no accumulation of phenolics. And then I put them outside in 3 different boxes. And in one box, I had a plastic plate shielding UVB and UVA. One only shielding UVA, and then the one open for UVA and UVB. And if you look to the plants, you can clearly see they looked very, very bad. I think, Victor, you saw the plants. They looked very damaged. And over the weekend, I gave them time to recover, but still you can see this is the plant which obtained full UVB and UVA, and it looks very, very necrotic. When we shield the UVB, but allow UVA, it's a few symptoms, but looks much better. And the plant where I shielded UVA and UVB almost looks fully recovered now. So this is clearly indicating that you need a protection, and you can have a very strong impact if the plant is not shielded properly by the UVB. If you want, we can pass that around. So, and this scheme shows that, again, the shielding effect of phenylpropanoids when they accumulate in the epidermal layer. And this is a scheme from a publication here showing that when you apply visible light to the plant leaf, it will penetrate, come to the layer where the chlorophyll is, and you will see chlorophyll fluorescence. If you use UVB or UVA or UVB light, you can also trigger chlorophyll fluorescence by that. But when the plant contains the phenylpropanoids in the epidermal layer, this light will not reach the chlorophyll, not this part here, and there will be less chlorophyll fluorescence. So based on that principle, there have been methods developed to make use of this chlorophyll fluorescence and to monitor the amount of UV absorbing compounds in the epidermal layer in the leaf. There have been two of these apparatus on the market since about 20 years. And one of the persons at the beginning and stimulating the development of these machines was Wolfgang Bilger. And this is one of my cooperation partners and also a partner for teaching at the University of Kiel. And this is the first apparatus developed by people around Erhard Pfündl and Rolf Gardemann. And you see this was published in 2005, and Wolfgang already was writing a review paper in 2001 because he knew the people and he knew the machine. And the second machine was then developed by French colleagues. And we had both of these machines available. I was using both machines at my laboratory. I was using both machines while teaching at the University of Kiel. And this gives me now the opportunity to introduce first my institute here, the IPK Gatersleben. It's, I think, the biggest plant research institute in Germany. We have about 500 people working there. A lot of fields around, so it's in a very remote area, in the middle of nowhere. Here, and here is Kiel, very nicely located in the close to the Baltic Sea. And I also can mention that last year we celebrated here the 50th birthday of this institute. This year, IPK now is celebrating the 80th birthday. So, yes, I was for teaching. I was frequently going to Kiel, and normally we did in the summer 2-week courses for students working on UVB stress using this type of machines. Now, I had spoken with Victor that we wanted to use this machine, and I will show you this in a minute, because the machine is something very simple to handle and it's non-invasive. You don't need to harvest the plant leaves. You can do multiple measurements on the same leaf, on the same plant. Now, we had spoken that we would like to use that also during the work here at the UCR, but unfortunately, both machines were no longer available. So Rolf Gardemann, the one closed his cellar for the machines. I was buying the last one, actually. And also the French company went bankrupt, and they were sold to an Austrian company, but they refused. We were writing emails. They refused to give continuous support. So, but luckily enough, now a German company called Walz, which is very well known for the different devices used for photosynthesis research, they said they want to start and build a new machine. And as I had contact to Erhard Pfindl, I mentioned he was on the first paper. He was a colleague of mine at the Institute, and we came in contact. He also knows Wolfgang Bilger, so it's kind of a network. And he said, oh yeah, we are developing this. Wolfgang had, of course, the information. And you are going to the UCR in Costa Rica. Do you want to test it? And in fact, they provided one of the first prototypes. And this was brought, it was not ready when I came. It was brought by Victor's son while returning from Germany. He brought it. So finally it came. So the machine is rather simple. So you have here a measuring head, and you put the leaf inside here, like that, and we can do it. Maybe I can ask Gretel to do some measurements. She's not very experienced. You just press, you have to calibrate, but you just press a knob and then you wait until the signal is. What's wrong? Here it was. So it's very rapid. And you can do a lot of measurements without destroying the leaves. So you can have a lot of measurements over time. And the information from this machine now is you're getting, they are using, you see it on the scheme, they are using, in one part of the head, they're using 5 diodes with different wavelengths. And then you can measure the screening. And this is new, 315 was not available in the other machines. 365 for the flavonoids, this is more for cinnamic acids. You can also have screening in the blue range for carotenoids. We have an indirect measure for carotenoids. Now they have added a diode where we can measure also anthocyanins indirectly. And the machine nicely is also giving a value for chlorophyll concentration and information about the photochemical quantum yield, which is diagnostic for the state of stress for the plant. The people supporting were Erhard Pfindl and Matthias Brügel. He's the engineer behind that machine. And we had many talks because this is a prototype and many things. There is no full description available in the moment. So I needed their help, and this is a very fruitful cooperation. So they call it the leaf state analyzer and should be marketed or come to the market in autumn. So we had to testing the prototype first to see if it really works or if it fulfills our expectations. I did this using a bauhinia tree, which is close to this building. And this bauhinia tree had different leaf positions, leaves which were fully exposed to the sunlight, but also leaves here in full shadow. And we analyzed these leaves. Paula, in this case, was helping. And we could see that low irradiance, the leaves had a low shielding, high irradiance, high shielding. And more or less, we could reconstruct a curve published earlier by colleagues from the lab of Barnes. Okay, I tested other plants grown in the greenhouse, but then luckily enough, we got access to to an experiment with coffee done at the iCafe Institute. And they have shielded. They have 4 plots, differently shielded, and there's the light available is ranging from 30% over 50 to 70 to 100%. And this was an ideal scenario to test also the machine and see whether or not we could reproduce with these measurements also the true levels of the phenylpropanoids. And for that, we measured first the leaves and later on took samples. HPLC work was done together with Andrea and Sebastian, and we could see this curve. You see there is many points are missing here. This is clear because already at 30% there is a certain amount of shielding. And we continued with light shift experiments. We also obtained plants from the iCafe small seedlings, and we could grow them in the greenhouse and grow also at 2 different nitrogen conditions, and then expose them to full light, measure the leaves in the morning, in the afternoon, establish the kinetics to see how it shifts from low accumulation to high accumulation, harvest leaves for HPLC, establish the correlation, hopefully, and verify also the peaks, identify the peaks. And this is important, and we are currently working on that because not all the phenylpropanoids respond in the same way. They are very selective, and therefore it is to interpret the data is important also to know their identity and to interpret the results. So, and this is, we had to make a team because we have measured a lot of plants. We have measured leaves upside down, several leaves of a plant, and both upside down and the correct orientation. And this was on Sunday morning, 7 o'clock, where we joined. And also Gretel did a lot of these measurements, and she's now an expert and can use the coffee data for her experimental study of this semester. And also Laura helped with data analysis, and but Laura will also, or has started her own experiment, but in this time using the Rescantia, a very nice ornamental plant. And this plant has the advantage that we have kind of patterns, different anthocyanin patterns, and this allows us to test also the 5th diode, the 5th wavelengths now here in the system, and check whether or not we can really also quantify not only the phenolics in general, but also the anthocyanins specifically here. And I think the start was given yesterday, and now we are waiting for the treatments, and I think with the beginning of next week, we will do the measurements regularly. So this is the experiment with Rescantia. And I would like to conclude and say this is, we have tested this prototype. I like to work with it. I see quite a number of applications. I think you can screen genotypes. You can assess your plants while doing a stress treatment to select and harvest at the right time to then make something like metabolic analysis, like transcriptome analysis, whatever. And I think it's also a nice instrument for teaching. And so, yeah, so I have to come to the end, 3 weeks only remaining. And of course, now when you are in a theater or in a music play, it is finished, and you would say like Shakespeare, Ende gut, alles gut. But this is not possible in science, because science is a continuous process. So we have still many things to be done also after the stay. And this is data analysis. We are sitting on un montón de datos, and we have to analyze this. We have to write the manuscripts, and I have to finish the courses whenever possible online, and the mentoring part. And I will talk about science with Wolfgang Bilger. I mentioned him several times. And during these courses, which we had in June normally, during this course, beginning, in the middle, or at the end, there was always the famous chess Baltica. And we are both aficionados, the chess. So we were always going there and enjoying our weekend. But of course, sometimes he brought his machines with him and we did some measurements in between. So I'm looking forward. And this is the organizer, Nils Landgren, a very, very good musician. And he's responsible for the program. It's a very nice place at the Baltic Sea, very nice to enjoy. And if you want to have a look, you will find many of the concerts from the last years also in the Mediathek of the German TV ZDF, I think. So I think we hopefully will have time to discuss these results because he always has clever ideas on these things. And so at the end, thanks again to the DAD, the UCR also for funding, and all the colleagues. I enjoyed my time very much. And I also have to thank my wife because she encouraged me to come here and she took the extra burden also with the work at our house, at our place. And during winter time, you can, of course, when there is enough snow, you can build a model of your partner who is in Costa Rica. But you also have to remove the snow. And the German authorities are very strict. You have to do this before 7 o'clock in the morning. So it's dark and cold. And we have a lot of space where we have to remove the snow from the pavement. And in summertime, a lot of gardening work. So I have to thank for that. And we are living in Goslar, very nice city. And it was very nice when I came to the office of Frau Rusak that she had a picture of Goslar. I think it was of this building. It's a very nice old town, a very historical town. Has a very long history, the area of mining, about 3,000 years. You can see this by mass spectrometry in the sediments of the nearby rivers. So this is a historical part of this. Very nice marketplace. Here were the buildings of the rich people. A very nice Christmas market. And this is the castle where the German kings were living 1,000 years ago. And close by, we have the Brocken Mountains where all this mining took place. And you can enjoy yourself going to the peak of the Brocken Mountain using this tourist train. So everybody is welcome. I'm happy to, I would be very glad if you visit me. I'm happy to act as a tourist guide. Yes, about funding your trip, I would recommend talk to Frau Rusak. She is here today. She will help you the best way she can find possible solutions with the DAD. Thank you very much. I forgot one thing. I said some special problems or events to this date. Anybody? Do you know what you did do on this date? Was a holiday? There was a match between Germany and Costa Rica. I felt really strange about that. So I don't know what would happen. And I said, what do I do on this day? So I decided I go to the lab. This is a safe place. So I went to the CIGRAS building, and there were the one CIGRAS building. There were only 3 people, and they saw me. They left. So I had the full building for me to do experiments. And I'm very grateful to both teams, and also the Spanish team and the Japanese team, because the outcome was that, there was no further competition between Costa Rica and Germany. It was finished. So this was the best outcome for me. Yes, and so the German tourists come back from Qatar and could come again to Costa Rica and spend their money here instead of Qatar. So it was a good outcome for me, and there was no negative impact for me from this match. And how can I know? And Christmas time, my Christmas bag was full as the others. So thank you very much.
Thank you very much for your very nice presentation with a lot of information, but also, yeah, nice experience. I want to ask you, as I have the privilege of deciding about the questions, and would you recommend someone to come, like in your case, for 1 year, considering all the first phase of difficulties that you had experienced, and yeah, will you
Yes.
encourage someone to apply
Yes.
for the head program?
Yeah, I think we decided very early that I would apply for 1 year and not for half a year. In hindsight, I think this was the right decision. You need some time, at least when you do experimental work and get more deeper involved in the running things. Half a year is very short. I even feel now that 1 year is also now running short, running out of time at the end.
Thank you. We are behind schedule, but if someone has a quick question, if not, we can continue. Okay, we continue. Thank you very much. And we switch to